So you can see here. So whenever you are going to go for transmission, you generally in the transmitter side you will be having a power amplifier. You will be converting the low frequency data into high frequency, and then you'll be sending it through an antenna. So this is our useful data, and these are adjacent channels which are going to have noise. So the always noise will be coming along with your signal only in wireless. So if the transmitter channel power is very large and noise level is very small, then I have no issues. But what happens if the noise power is also going to be equivalent to your signal power, or it is more than your signal power? So the receiver, you see, you have the antenna, you have the same band pass filter, you have the low noise amplifier to get back your signal. Okay, what happens? See here, the desired channel power is less, the adjacent channel power is more, the other adjacent channel power is even more larger. So in this case, there is a strong assumption that your desired channel will be completely filtered out. It will not go into the circuit at all. The receiver must be intelligent enough to pick the desired channel from these three signals, rejecting your adjacent channel, which is your noise, and another adjacent channel which is also having a larger power, but those two are not my desired signal, but my desired signal is having a very less amount of power. So this they use the term in band and out of band interferers. So in band means close to the desired signal, whatever you have, it is in band, and when it is far away from the desired channel, it is going to be out of band. So in band and out of band interferers have to be completely rejected if your receiver has to do its job perfectly. So this is a very commonly faced issue in wireless communication. Either way, wired, this issue is not there because the power transmitted to the transmitter will be almost the same at the receiver, excepting the losses. But in wireless, since I am not able to predict how the channel is going to behave at different points of time, your receiver must have the intelligence to process the desired signal accordingly. Okay, and both when you're going to cascade the different stages, the non-linearity and noise will also increase. Cascading will increase your gain, it will increase all your distortion, it will increase all your noise, everything. So the linearity of the device should be very high to ensure that all the interferers have to be completely cancelled out. So if we can simply filter the interferers, you can relax the linearity requirements. So see, removing the interferers is only my goal, means then you can slightly compromise the linearity. But if your linearity is compromised, then harmonics will come into picture. So a lot of issues are there. If you touch one parameter in wireless communication, you should think twice before disturbing a parameter. Okay, so just here what issue is, if you want to filter out interferers, I can compromise on linearity of my receiver. If the receiver linearity is compromised, then harmonics will play a role. So interferers point, we are unnecessarily introducing harmonics. Harmonics will also do the same job as the interferer. So how can I compromise, or how can I arrive at a conclusion between the two? So see, we are going to consider a case where I'm going to have interferer which is going to be away from the desired signal. So one or two channels away from the desired signal.